can invite Shahin Mamedov. Shahin, are you around?
And so I stop sharing then.
Yeah, please. Thank you.
Mhm.
Hello, everybody. So, thanks to organizers to giving me for giving me opportunity to give a talk here. I'm sorry, my camera is destroyed, so it's better I will turn off it.
Shahin,
So,
if you are in trouble, just make a sign. You seem to be at the
so
hot.
it's okay.
Okay.
Okay. So, do you see my screen?
Yes, Shahin, we can see it.
Okay.
Yep.
Okay. So, talks here, all talks here devoted to AdS QCD and related topics, mainly to related gravity. But my talk is related to phenomenology of particle physics, the relation of application of AdS QCD to phenomenology of AdS to phenomenology of particle physics. So we have calculated coupling constant of tensor mesons with nucleons and decay constants of tensor mesons using AdS QCD models. So, short introduction. Why mesons? There are rich experimental data bias for the low energy QCD. So a lot of experimental groups working, measuring different quantities of hadrons. So tensor mesons also was detected experimentally, and holographic models can be useful for the study of tensor mesons. Quark content of tensor mesons is U and B anti-U and anti-D quarks, as you see. So mass of tensor mesons F2 1270 MeV approximately. So decay widths shown here, and most probability decay widths is F2 meson 2 pions. Most probability decay. Okay. Some words about AdS QCD. After appearing AdS CFT, so it was started to construct models which are useful for the QCD problems. There are two approaches now, two approach in AdS QCD, top-down and bottom-up approach. Bottom-up approach is appeared in this first papers. In these papers, and indeed in earlier works can be seen solutions for the scalar and vector particles quibbles in earlier works. So, okay. There are two main models AdS QCD, hardware model and software model. So matrix is the usual 5D AdS space in planetary coordinates. And uh, first one is Hartwell model is just cut off AdS space at some value Zm. So in order to make 5D action integral finite. So if we take integral over the finite range of Z, then action integral will be finite. So another way is introduce some warping factor in such a way phi z is a dilaton field, and in this case also action will be finite. So that's why they are called hard and soft wall models. Okay, how to introduce tensor mesons in AdS QCD models? So it's in the bottom-up approach of AdS QCD. Tensor mesons for the first time were introduced in the work by Katz and Toll. So in this work, so speaking about tensor mesons, I mean spin 2 tensor mesons. There are other tensor mesons, spin 3, 4, 5, and more, but we shall study spin 2 tensor mesons, which were considered in this work for the first time. Okay, and we follow to this work to present here tensor mesons. So since tensor mesons and graviton both have spin 2, so authors decided to use solution for the graviton for the tensor mesons as well. We shall see that there are two ways indeed to get to solve equations, to get equations and solve equation of motions, and they give equal results, equal solutions. Okay, so let us consider small linear perturbations of AdS space, and H is perturbation, which is described by tensor field and described into graviton waves, gravitation waves, graviton. So action for the H has such a form, obtained from Einstein equations. So this can be reduced to this form equation, and applying Kautz-Klein expansion, this Kautz-Klein expansion, it can be obtained equation for the mode HNZ. Oh. So this is MHN is mass of the nth mode. Okay, general solution to this equation is expressed by Besser functions J2 and Y2. So applying boundary condition, boundary condition H at 0 should be 0. This means beta n should be 0. And applying infrared boundary condition, Hm at Zm should be 0. Quantize the mass spectrum by the rule, by this rule. So normalization condition is usual. So finally, profile function H and Z is found in this form, expressed by J2. So okay. So now consider tensor meson profile function within the software model framework. Consider general action for the spin S field in the software model. This action has such a form, and as indicated by authors, the m square term here is ignored. So this is a general form of action, general action for the spin S mesons. So we take here S equal to, and make a Kaufman expansion applying, and the equation of motion reduced to Schrödinger-like equation for this phi tilde. Another way to get equation of motion, as I said, to consider the spin tensor mesons as similar to graviton field, and to get equation of motion from the Einstein equations. Of course, in this case, we introduce this warping factor, this dilaton field. This exists in Hardwell model also. Okay, so transverse and the traces gauge conditions were applied. Then equation of motion reduces to this form for the mode Hn, and we make a change, such a change. Then we obtain again Schrödinger-like equation. This equation. So this solution of this equation and this equation are coincide. We have shown in our paper that this solution of these equations coincides, is same. So we indeed have two ways introduce tensor mesons. Okay, normalization condition, this one applied in order to find this normalization constant. Okay, so nucleons in AdS QCD is studied very well. So in the Harpole model was used in this work, and I should say that to describe nucleons in the boundary, it should be introduced two independent five-dimensional Fermi fields, psi left and psi right, in the bulk of AdS spacetime. This is because left and right components of the nucleons in QCD should be independent ones. So here psi left and psi r are independent fermions. So usual action, five-dimensional action for the spinor field, which is the extension of four-dimensional direct equation. From the action can be equation of motion obtained, and solution are expressed by means of, again, by Bessel functions. So we now profile function for the tensor meson and profile functions for nucleons. Now here we presented also in the software model profile functions as well, which is very well known in the literature. So I did not present it here, derivation of the equations and their solutions, but just only presented solutions. Okay, so now we should construct interaction Lagrangian between tensor field HMN and five-dimensional spinor field. How to construct interaction Lagrangian for these fields? So we can use four-dimensional model Lagrangian. So in four-dimensional Lagrangian for the tensor meson and nucleon interaction is known. This is Lagrangian for nucleon and tensor meson interaction. Two kind of terms here introduced. So we should extend this Lagrangian to the five-dimensional case and AdS spacetime. This is written in flat spacetime. As you see, ordinary partial derivatives. Okay, so we can write action in four-dimensional flat spacetime in momentum space. So we shall get form of four-dimensional action, explicit form expression we have for it. Now we extend four-dimensional Lagrangian to the five-dimensional theory in AdS spacetime and replace partial derivatives by covariant derivatives. You see the same form as Lagrangian, just only. Okay, this Lagrangian is Hermitian and covariant as covariant form. Okay, so five-dimensional action in AdS spacetime after applying explicit expressions for psi and H menu, we shall get explicit form in integral representation of for the F2 meson with nucleons. So as you see here we have same structures. So same tensor structures. This one coincides with this one, and this one is coincide with this current, this tensor current. So I should express that this is a tensor current of nucleons, because it has two kind of tensor structures. This kind tensor structures and this kind. Okay, so in our also same structures we have, but here stay coupling two kind of coupling constants.
Shahin, you have about 6 minutes.
Sorry. Okay, thank you. Okay. So from the comparison we get expressions for the coupling constants, which is 5-dimensional integral over the extra dimension. Okay, then we can numerically calculate couplings, and to compare with the result of other models. So this is holographic. This is results for a holographic model. Was holographic model. This is another models. But there is no experimental value. So this is just only values of predictions of models can be compared. Okay, so another way is to calculate vector meson tensor meson decays F2 to rho meson, F2 gamma rho, F2 gamma gamma. So again we write action. This noun action and 5-dimensional and 4-dimensional. This is its 4-dimensional part. So we write it in momentum space. Okay. So also from the old work, this work is known Lagrangian for the tensor meson decay to vector meson. We comparing this 32 with this expression, we see that same structure, tensor structure, has both actions, and then we can find this alpha, beta, gamma, delta constants. So finally, this using profile functions for vector mesons, which is very well known from the earlier works here and in software model, this ones. Again, you see by Bessel function and Laguerre polynomials. So this is another kind of interaction. This minimal interaction is called. So this is also can be calculated in the same way, and in the tensor meson case, model case, also couplings can be calculated as integral over the z variable. Okay, similar calculations for tensor meson photon interactions. So this is a prediction by Hartwell model. This is profile function. So this is predictions of other calculations, other models, and this is a prediction of our AdS QCD model, Hartwell model. Okay, I am finished. Thank you.
Shahin, thank you very much for this nice presentation. Are there some questions? Shahin, can I ask you one?
Yes.
So what are the numerical inputs to produce these numbers? I mean, what are the numerical inputs that you take, like lambda QCD or what?
Numerical what? Indeed, we don't deal with this numerical values for couplings is just only experimental values. There is no experimental values for this couplings yet. So just only theoretical predictions, and theoretical predictions can compare which one is another one. So, and I presented the results of AdS QCD models.
Okay. Are there any other questions? Thank you again, Shahin. And next, we are going to hear Salman Sajid Wani talking about quantum information aspects of the problem of time. So you can